Hello students. So I'm going to explain the next experiment. The name is Vignier cipher. So I'm going to implement in C. Before that, I want to tell the definitions regarding the Vignier cipher. So what is meant by Vignier cipher? So you already know Vignier cipher. You already before the previous before this experiment, you may heard of a previous exercise, that is Caesar cipher. Okay, so the same, it is like the same like Caesar cipher. The Vignier cipher is a kind of polyalphabetic substitution method. So substitution method, it is used for encryption of alphabetic text. For encryption and decryption, Vignier cipher, the below diagram mentions about Vignier cipher, how the encryption decryption takes place. Okay, so I put some diagrams regarding the encryption decryption process, so that you can easily understood what you can correlate with the program, so that you can easily understand, right? So nothing but it is a substitution cipher, right? Okay, polyalphabetic in the sense multiple alphabetics are used for doing operations, so that is said to be polyalphabetic. So we frequently did our substitutions, so the polyalphabetic, it is termed as a polyalphabetic substitution, nothing. Okay, so this is the major one. Actually, what is this means is nothing but a matrix. See, this is nothing. This part represents a key, and this part represents the plain text. Okay, so nothing but we are going to input encrypt through this table only. Okay, actually what it is in the table means, this table is known as a Vignier table, right? So Vignier table is nothing but they are going to encrypt like this. How means they are going, if hello, for example, hello means hello, and my key is cat, then first letter is H and second letter is C. So they take H from this part and C from this part, and through this row and column, it converges on this part, it meets on this part. So H and C. So this is J. So J will be taken as an encrypted text. Likewise, for every character that this table will be, this Vignier table will be frequently analyzed, and it will be, and the row column meeting point will be taken as a ciphertext, right? Okay, so I will tell through some of the examples, right? So this is the same table. It is like a same table. The left hand side is a key, the top term as a plain text. Okay. Okay, so actually see, actually what here the major one is, the alphabet will be 26 alphabet. So A, B, C, D, F up to Z. So A is 1 and Z up to is 26. So we can take the key as CAT. Okay, for example, key is CAT, then C will be, C is an third letter from the alphabet, A is a first letter, and T is a 20th letter. Likewise, plain text. So if we give some input messages, instruct tables. So if I is an I comes from 9th letter in the alphabet. So I is a 9th letter. N is a 14th letter, right? S is a 19th letter. Likewise, for understanding purpose, I am telling this. Okay. So how this works? How the encryption decryption works? Okay. So I am telling. So how the encryption works means. So okay. So if for example, take take the plain text as a crazy programmer. The crazy programmer is a plain text. If the key I am taking is hello. Okay, if I am taking the key as hello, the first thing I will do is I need to generate the key equal to the length of the plain text. Okay, so hello is a 5 letter plain key. character. So here it is much more than the 5. So I need to multiply this like hello 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 up to what, up to the length of the plain text. Up to the length of the plain text I need to generate a new key. So only I can compare with the for example, if t with the h with the e with l, c with the l, r with the o. Okay, the mutual comparison will take place, no? So that I can multiple the key may be whatever length, so you can multiply up to the length of the plain text, so that we can compare with the we can see the we can see the Vignyer table, and we can substitute we can replace the plain text with the correct ciphertext. Okay, see here T and H. So what the encrypted message is A. Okay, how the T and H gives A? See here, see in the table, you see okay, see the crazy. So T, sorry, example, the crazy. So T, see T H, T H. So the crazy means first letter is T and H is hello. So first letter T with H gives what? A. So only they are giving encrypted messages A. Likewise, every letter will be substituted for the appropriate converging point with the particular key value and the particular plain text value. So nothing but we are going to get the message from the user as a plain text, and also the key from the user. So the key will be multiplied depends upon the length of the plain text. After attaining a particular length, equal length, we are going to compare both the letters. We took both the letters, and we will check the converging point from both the letters in the Vignyer table. So that letter will be added as an encrypted message. Simple. Okay, so in the diagram point of view, this diagram is for your convenience. Okay, so this diagram is actually, it is for your convenience only. Okay, here what see, okay, encryption, how the encryption takes place. The diagrammatically, see here some examples I am going to give. For example, if I take the key as CAT, for example, leave that example. If I take a new example as, if I take the key as CAT and my plain text as instructables is my plain text. Instructables means what? I represents 9, N represents 14, S represents 19th letter in the alphabet. So that this represents that thing only. See, so the simple key is CAT. I need to multiply this CAT from off only up to the length of the plain text, right? So what is C? C is a third letter, A is a first letter, T is a 20th letter. Likewise, so here what they are doing, they are 9 plus 3 is 12. So they are going to 12, they are going to subtract 1 point, and they put as 11. So 11th 11 represents what? 11th letter represents K. Okay, and also A and N, first letter, N is 14th letter, 14 plus 1 15, 15 minus 1 14. So 14th letter represents N. So these are the ciphertext values. Okay, C and I represents K. So go to the table and see C and I represents what? K. Okay, C I represents what? K. So only the formula, this is how the formula works. Okay, so you need to subtract the plain text letter with the key, and you need to subtract 1 point, and that letter will be compared with the original alphabetic letter, so that key will be taken. So this letter is an ciphertext. Understood? Okay, this is how the encryption works. Okay, so in the mathematical point of view, it is simple that the ciphertext, this is a formula for generating the ciphertext. What is this? Is nothing but a plain text letter is added with the key, and it is we will take the mod operation 26. Okay, so what is plain text letter with the key and mod 26. Okay, so first plain text letter and the first key, and we need to add both, and we need to take mod 26 with that. If for example 25 mod up to 25 mod 26, the answer is 25. You may aware of mod operations. If 1 mod 26 is 1, 2 mod 26 is 20, up to 25 mod 26 is what? 25. Apart from if 27 mod 26 is 1. Okay, you may aware of a mod operation, right? So while doing this mod operations, okay, so you may get the encryption values, so that that encryption values, the appropriate encryption letter will be taken. Okay. Okay guys, for example, if you take PI plus KI mod 26, the answer will be the encryption. I told no. So see, for example, let us take C with the D. Okay, C is a third letter, D is a fourth letter. So C is a plain text and D is a key. So third plus fourth letter seems what? Gives what? 3 plus 4 is 7. So I already know 7. 7 mod 26 means what? 7 mod 26 is 7. So C plus D gives what? F. F is a which letter? 1, 2, 3, 4, 5, 6, sixth letter. So in the diagram itself, I already told no. Okay, so the two letters are added and one is subtracted. That is what saying here. So we need to subtract. First we need to add the plain text with the ciphertext, plain text key with the key values, and we need to did mod operation, and after that, after the mod operation, we need to subtract 1 point so that we can get the ciphertext individual character. Likewise, we are oftenly doing for every messages. Okay, likewise the messages are encrypted. The same we are doing for decryption also. So in the decryption, how this works? Actually, during decryption, actually I took it from the net for your understanding. The decryption C, for example, A, B, C, D, E, F, G, H up to Z is a plain text. We know. So CAT means we need to like hello. So up to the how much times we doubled for reaching the plain text length, so that we are putting here CAT. So for decryption, we got the decrypted ciphertext. So the ciphertext will be compared with these letters, and that row by row, that for example the ciphertext is K. What is K? K is here. What is straight to the K? I. So I is a plain text. Here also N. What is straight to N? N is a N is a plain text. So the ciphertext is for ciphertext L. So we need to refer through step by step. So first row, second row. In the third row, what is L? So L is here. The L represents what? The L. So L for what is straight to the L? Yes. So yes. So likewise we move up to the end of the process. We need to iterate up to the end of the process. Okay. So what is here means C D E F C D E F G H A B C D T U A U V W, likewise C D A T. So these are nothing but we are the same operations we did at the Vignette table. This is what so this is majorly we used in encryptions, sorry, decryptions. Okay, so so this is what happening in the decryption part. Okay, so alphabetic, key and ciphertext. So we already have an alphabet, we already have a key, and we took the ciphertext as input point. So the ciphertext as now take the ciphertext key and so the ciphertext operations I already told at the initially here. Okay, this is what. So for encryption, we need to add the plain text to the ciphertext, and we need to take mod operation, mod 26. Okay, in the ciphertext, in the decryption part, we took the encryption text, and we need to subtract with the key, and we need to add 26, and after the answer we need to did mod operation with the values. That is what I told in the this part. So nothing but we need to this part. Okay, so likewise the decryption works. Okay, so nothing but plus is we need to add the plain text with the key and did mod operation for encryption. We need to subtract and we need to add 26 for decryption. This is what the decryption and encryption tells. Okay, so what we will use in the program. So nothing but I told about the algorithmic part. So see the program, how the program works. So these are the header files, you may aware. So the input is we need to get the input message, that is the plain text. So character message of this is the plain text. Okay, so this is the plain text, and we need to get the key. So this is the key, and we need to get the message length. What is the message, so that we can double during key generation. If the key is not up to the length of the plain text, we need to double the key up to the length of the plain text. Okay, so int message length is equal to string length. So that only we are using string length, and key length also we need key length also. So only, so it is an input is in the form of character data type, and we also use the variable encrypted messages and decrypted messages. Okay, it is in the form of array, so that we can we can iterate up to the end of the plain text. So we can use array data type here. So the first operation is we need to generate a new key. So how the new key is generated? So we need just be up to the key. We can we take the input as a message length. Message length is nothing but the plain text length. The plain text length is up to the plain text length, the key value is doubled. So the new key is generated in this part only. How it is generated? For every I value, for every j value, it is incremented up to what? Up to the length of the message. Okay, so I already initially told in the so the plain text, the plain text and the key length will be in equal length. So we can if the key is minimum in length, it has to be doubled up to the length of the plain text, so that here the key length is oftenly checked, and the I value is incremented, and it is incremented, and the for I value and j value is incremented up to what? Up to the key, up to the message length. Up to the message length, the key length has to be the array value, the I and j value will be periodically substituted up to we will get the length of the message. Okay, so this part tells about, so up to what, up to the end of the key. Okay, so after that the encryption part. So how the encryption part works? The encryption part works by, I already told, no, what's plain text plus key, p of I plus ki plus mod 26, that is what I told, no. So here the same thing, this is a message is plain text and key value is ki value and mod 26, this part. Okay, so agree. So for I is equal to 0, I less than message length, I plus plus I. So how it up to what, up to how many times it iterates, up to the message length of the message, it iterates, the p value and I value will be compared, and the converging point will be taken as an encrypted message. For example, message of 0 plus new key of 0, the 0 and 0th position will be compared. For example, the 0th position is H, L, T, and the keyth position is H, and T and H will be compared, and A, the converging point A will be taken, that will be stored in the message of I, encrypted message of 0, அதே மாதிரி encrypted message of 1, encrypted message of 2, encrypted message of 3. Okay, likewise up to the end of the plain text and the key, the iteration takes place, and the converging point in the Vignyer table will be oftenly checked, and the converging point will be stored in the encryption of encrypted message of ith array up to the end of the plain text. That is what the encryption works. Okay, so how the decryption works, I already told. Decryption is nothing but a plain text, with a cipher text minus key plus 26 mod 26. That is what the algebraic notation tells. So the decryption, same like encryption, the decryption also works like this only, up to the encryption message of I. See, the encrypted messages will be taken, the single that individual ith position will be periodically incremented with the key value, and it is added with the 26, and it is mod 26, and it will be stored in the decrypted messages up to what, up to the end of the string. I already explained the theoretical part clearly. Okay, so likewise, so here the original message will be printed, the key will be printed, the new generated key will be printed, encrypted message and decrypted message will be printed. So this is what the output comes. So for example, if you give a message as like this, the crazy programmer, the key is hello, the hello will be doubled up to what, the length of the original message. So that is compared, T, H, H, E, E, L will be compared, and then encrypted message. After the encrypted messages, the decryption messages will be found. Okay. So this is what about Vignyer cipher. Thank you.